Microdian.
These chips are the key source of the emission. A shunt capacitor can be used to reduce the EMI difference between probe and the EM scanner. Hi, I'm YJ Liao from INSTEK. We have an easy and useful EMI pretester solution which can help you to find out the EMI source, to improve and to accelerate the process of passing the EMI certification. Today, I am going to demonstrate how to use the pretester solution to find out the EMI source with high efficiency based on a real example. First of all, I will test the EUT in EMI chamber. Then, based on the stronger EMI signals, I will use our EMI pretester solution to find out the key circuit and area of EMI in the EUT. I will also give some EMI improvement advice in terms of the example today, and I will compare the difference between EM scanner and our solution. Finally is the summary. This is the EUT for today. We will test it in the EMI chamber. And this is the outcome. These two signals, 400 MHz and 600 MHz, are the strongest ones. So in today's case, we will set these two EMI signals as our goals. Now we move to my office and we'll use the EMI probe and the spectrum analyzer GSP-9330 to find out the EMI source. First is to set up the spectrum analyzer. The GSP-9330 has a special mode for EMC pretest. Press the EMC pretest button to start. Activate it. And select the testing frequency band. And now it's ready. Before using the probe, there is nothing on the display. Now we connect the probe to the GSP-9330. The EUT is not turned on yet. And we can see that my office is full of wireless signals. These are FM signals and the others. Because this office is by the window, lots of wireless signals are detected. Since our focus of today is the 400 MHz and the 600 MHz, let's just highlight them with the marker function so we can check them easily. Marker 1 at 400 MHz and the marker 2 at 600 MHz. Then back to EMC pretest mode. Next, we're gonna open the EUT and turn it on and use the probe to check inside. Okay, now we have removed the metal case and turned the power on. Please remember that our purpose is to find out where it gets the strongest 400 MHz and 600 MHz signals. As for others, let's just put them aside. The signal emission from this chip is strong, and the nearby circuit is the same. And this chip is strong too. These chips are the key source of the emission. The flat cable is strong because it's just like an antenna to radiate the signals. The power section is not so strong. The vertical PC board in the front emits the signal too. Here we need to be careful that do not touch the metal ground of the probe or cable while using it, so those unnecessary signals won't be detected through our body. Let's take a look at the mechanical structure. Metal base, front plate, back plate, and a case can prevent EMI from leaking, but the necessities like vents and I/O terminals will leave some gaps and cause the leakage of EMI. What's more, the button circuit and the LCD set on the outside of the front panel will also cause the leakage of the interior EMI. Next, Let's assemble the EUT and use probe to check from where the 400 MHz and 600 MHz signals will come out. Now the EUT is reassembled and turned on. Let's check the button below the LCD first. And the LCD. These two signals are strong here. Move to BNC terminals. Here the 400 MHz is stronger than 600 MHz. It's pretty obvious here. Then the button area seems better. Now to the top, the joint of front panel and the case. It seems okay too. Then it's the left side. Some bands are here. And the right side. Now check the back side. Both signals are strong over here. We can see that these two signals are everywhere, but the 400 MHz is stronger around the front BNC terminals. As for 600 MHz, it's around LCD and the terminal on the back. As for the EMI from the chip, a series resistor or shunt capacitor can be used to reduce the EMI of the clock signals and their harmonics. As for the gap between metal materials, you can fill it with EMI gasket so as to prevent the EMI leakage from inside. Those from the buttons, you can use multi-layer PC board, which the top layer has to be ground. Needless to say, that might increase the cost. Or you can detect the button pushing by interrupt instead of pulling. As for those from BNC terminals, you can change them with different grounding design. Like this metal terminal could be a better choice than the plastic one. Recently, someone asked about the difference between our probe and the EM scanner like this. Generally, this type of EM scanner is for PC board. Before the testing, you have to wire the power and all signal lines so that the EMI can be detected under a condition of full function operation. If the product has not only a horizontal PC board, but also a vertical one, a piled one, or the one located in a finished product, then it's not that easy for EM scanner to find out the source. Just like our example for today, the device is wrapped with metal case. The EMI is leaked from the gaps, then we have to use the probe. Maybe you have shared the same experience that wasting time on solving EMI problems and the exorbitant charge of the EMI testing lab. Our EMI pretest solution has allowed many engineers to shorten the time of solving EMI problems and even reduce the frequency of using EMI testing lab.